Hi everyone and welcome back to Maddie Wizard. Today we're going to be talking about electrolytic cells. Electrolytic cells involves the use of electrical energy from a non-spontaneous power source or outside source such as a battery to then convert into chemical energy. Just like in a voltaic cell, electrons are flowing from the anode to the cathode, and we can remember this through the acronym NOx-RED-CAT. An for anode and ox for oxidation, then red for reduction and cat for cathode. Unlike in a voltaic cell where you have two separate containers or two separate cells, in an electrolytic cell you have one shared cell and there is no salt bridge. So in the electrolytic cell we typically have an electrolyte. We typically have an electrolyte solution that contains ions that will actually allow for there to be a maintaining of balance. So unlike in a voltaic cell, the anode is the positive electrode and the cathode is the negative electrode. Now, in a real life situation, we can use electrolytic cells for something called electroplating, where you plate or cover a cheaper metal with a thin layer of another metal on an object. And in electroplating, the cathode is the one being plated and the anode is the plating metal. Lastly, the battery or the non-spontaneous power source in this electrolytic cell is forcing the electrons into the cathode. So it's pulling the electrons away from the anode and pushing it through the cathode, which is allowing for the reaction to happen. So here we have an electrolytic cell. And in the setup, here we have one container filled with an electrolyte solution and two electrodes connected to a battery. So once again, the anode is the positive electrode and this is where oxidation is going to occur. So the battery is going to pull the electrons away from the anode, causing the metal at the anode to lose electrons and form positive metal ions, also known as cations, that enter the electrolyte. So here we have the battery pull electrons away from anode. So it loses electrons, forming cations, and they enter the electrolyte. However, through the battery is where the electrons are flowing. So now the cathode is the negative electrode, and this is where reduction is occurring, so where it's gaining electrons. So here the battery is pushing the electrons towards the cathode, making it negatively charged. So now the positive metal ions or the cations that we had from the anode, right, which are now in the electrolyte solution, they are going to attach to the negative cathode. And when they reach the cathode, they're going to gain electrons and become neutral metal atoms again. Now these atoms are going to stick to the surface of the cathode, which is going to allow the cathode to become thicker. And this is the process of electroplating, where the cheaper metal object is coated with a thin layer of another metal. Now the negative ions that are already in the electrolyte solution are going to move towards the positive anode to help maintain the charge balance. So always remember that in both voltaic and electrolytic solutions, the cathode is always going to attract cations and the anode is always going to attract anions. So the electrons are always going to flow from the anode to the cathode through the circuit, through the battery, while ions are going to move through the electrolyte. So just to summarize, because we have a battery that's connected to the electrodes, it's going to suck the electrons out of the anode and it's going to cause oxidation because it's going to cause the anode to lose electrons. And since the electrons are leaving, the anode is going to be left with an excess positive charge, which is what's going to make the anode positive in the electrolytic cell. And since the battery is going to then pull in those electrons and push them onto the cathode is then going to take on a negative charge, and where it's going to reduce and gain electrons.